All right, welcome back. We are doing another math video today. Today we're talking about cones and pyramids. Cones and pyramids. All right. So, if we imagine a cone, let's just start with a cone. Bam, bam, something like an ice cream cone or something like that. We want to be able to figure out the volume of this particular cone. We want to be able to figure out how much stuff, how much ice cream can we put into our cone. So, the way we do that. Ooh, wow, that's fun. That moved all over the place. All right, cool. The way we do that is we need to know a couple things. First, we need to know the radius of the base, and then we need to know the height. So the distance from, essentially doesn't make a triangle, but the distance from that center point to the top of the cone right here. So if we take things that we've already done, and we turn this cone, and we take this cone, and we put this into a cylinder that has the same top and bottom as our cone. Let's see if I can do that a little bit better. There we go. So yeah, imagine this is touching the center of the bottom of our pyramid, of our cylinder. This cylinder, again, we would need to know our radius and our height, because our formula for our cylinder is volume is equal to pi times our radius squared times our height. So for a cone, it's very, very similar to that, and it's the exact same formula, just divided by 3. We take that formula and divide it by 3 to get this volume here compared to the volume of our cylinder. Okay? So let's do an example really quick. So let's say that we have a cone that has these particular volume measurements. All right, I'm going to just go ahead and erase the rest of our cylinder. It's actually a really fun trick. You can actually, if you get a piece of paper and like some popcorn or something like that, and you make that piece of paper a cone that fits that cylinder exactly, you can take and pour that popcorn in, and it will be exactly 3 times. But let's say we have a cone where we have a radius of 7 units, and our height of our cone is, let's say, 25 feet. So we take our volume equation, V equals pi times our radius, which is 7 squared, times our height, which is 25 feet, over 3. Okay? Hammer that into a calculator, and you get 1,282.8 cubic feet. That's our volume of our cylinder. All right, and so then if we move on to say another shape like a pyramid. All right, so those big pyramids out in Egypt. So if we have our pyramid, we need to be able to find the area of our base and the height from the center, the height to the point. All right, just like with our cone, if we take and we make a rectangular prism with this as our our shape, our cone type object, our pyramid type object that fits inside this rectangular prism. Wow, this is not going well. Pictures are hard, but we need to draw them so we can try and make this accurate. Yeah, there we go. All right. So now, hopefully you can imagine this pyramid sitting inside this prism type box, and then the point of our pyramid is right at the center of our box. So same idea, where whenever we're finding a prism, it's going to be volume equals whatever our base is times the height. Or in this case, since we have a rectangle, we have length times width, and then we have our height. This is going to be volume equals length times width for our base times our height for our pyramid. Just like with the cone, the pyramid, all we do to find our pyramid, So our volume of our pyramid is going to be length times width times height over 3. Okay, so all of those shapes that we've been working with up until now, they all work exactly the same way if we go from a prism to a cone, or a prism to a pointed object that fits inside that prism. Prism to a pointed object, we're just going to take the exact same formula, but we're just going to divide the output by 3. All right, so let's take a look at an example. So let's say we wanted to find out how much rock is in the Great Pyramid of Giza. So we have our, excuse me. Let's say we have our Great Pyramid of Giza, sitting out in Egypt, and we want to find how many cubic feet of rock are in this Great Pyramid. Okay. So let's see here. There we go. Let me try that again. There we go. Okay, so we have our Great Pyramid. All right. So we need to know. We need to be able to figure out how big the base is, and we need to be able to figure out how tall it is. All right. And a quick Google search will pull up that the Great Pyramid of Giza, which is temporarily closed, thank you COVID-19, you jerk, our Great Pyramid is 455 feet tall, so we can go ahead and we can say that this height right here is 455 feet. And then that same search tells us that it is 756 feet on each edge. So 756 feet on each edge. And this happens to be a square, so it's 756 feet on both sides. Okay, so if we take all these numbers, we take our volume equation, V equals length times width times height over 3. V equals 756 times 756 times 455, and we take and we divide that by 3, we get a number. And that number is a big one. That number is 86,682,960 cubic feet. All right, there's a lot of rock there. All right, but cones and pyramids, super straightforward. Just take those prism formulas that we had and divide them by 3. I'm going to go ahead and I'm going to update the formula sheet to include all these on there, and I'll attach it to this to go along with your assignment for this. All right, have a great day, and I will see you guys later. Bye.